Welcome to this course. This is a short introduction to application of radioisotopes in medical diagnostics and therapy. Nuclear medicine in short. When we say nuclear medicine, I think in this expression even the word nuclear has a negative meaning, something frightening for the general public. Still, it comes now together with another word, medicine. And this is not just a coincidence. It demonstrates that all those dangerous radiations like alpha, beta, and gamma radiations can be beneficial for us. They provide surprising opportunities to serve healthcare. I have to add that nuclear medicine is something that may seem to be even more fearful. This means that we go to see a doctor and he or she injects a radioactive substance into our body. Isn't that ridiculous? No, not at all. The radioactive isotope may provide invaluable information to the doctor for healing. This can be crucial information about the type and severity of our health problem, or it can cure us directly. Everybody has experience on medical X-ray investigations. That is not nuclear medicine. That is radiology. When using X-rays, only the radiation is used, taking advantage of the fact that our body is more or less transparent to this type of radiation, and the internal structure of our body can be visualized. The reason why nuclear medicine is worth teaching is simple. One has to convince people that just like some chemicals that are dangerous when used in large quantities but beneficial in small doses, the same is true for the ionizing radiation. The excessive fear from radioactivity due to historical events like the attack on Hiroshima and Nagasaki should be released. Now let us see how this story unfolded. We have to go back in time to the year of 1895 when Konrad Röntgen discovered the X-rays. Only one more year passed and Henri Becquerel discovered radioactivity. I think today radioactivity seems to be much more fearful than X-rays because we are quite accustomed to X-ray investigations for medical purpose, but it is a fact that the vast majority of the victims of this ionizing radiation came from the application, kind of a premature application of X-rays, because that time nobody thought that application of X-ray could be dangerous. This is a picture from Hamburg, Germany, actually a monument to the X-ray and radium martyrs of all nations. The number of names carved into these pieces of stones is more than 350. The majority of these names are the victims of the application of X-rays. The rest is the radium martyrs. What does it mean, radium martyrs? It happened actually more than 100 years ago that in New Jersey, in the United States, there are some ladies painting clock faces with some glowing paint. That's why they use radium. And since they were supposed to apply very thin lines, in order to sharpen the pencil they used, they put the pencil into their mouth. And by doing this for a long time, they slowly ate a radium-containing substance. Many died because of this. So it was a very, very serious lesson to learn that if you use radioactive materials, you should be extremely careful with it. Probably you are familiar with this picture. This photo was taken shortly after the Chernobyl accident, which happened in 1986. It was a fatal accident. More than 30 people died shortly after the accident itself, I mean in a few weeks. And in the past several decades, thousands of cancer cases were detected. So this event sent another message to mankind that maybe the application of radioactive isotopes can be very dangerous and you may be better off avoiding this. However, it is not exactly the case. I can show you easily how the dangerous ionizing radiation has been turned to serve mankind to improve our health. Actually, what I offer to you is a study plan. This study plan has several chapters. Of course, there are some very simple materials, so if you are familiar to any of these, you can simply skip it and go to the next chapter. The first chapter is about nuclei and their stability. In this chapter, you can learn how a nucleus can be built from protons and neutrons and what are the basic conditions for the stability. Once a nucleus is metastable, you will observe radioactive decay. In this chapter, you can learn what alpha decay means, what the several versions of beta decay means, and also you can learn how gamma radiation forms. Then the next one is a very important chapter. It will discuss the types and properties of ionizing radiations with special attention to the interaction between matter and radiation. Solely on the basis of the properties of gamma radiation, you can learn how in nuclear medicine this can be used in diagnostics. To understand the therapy, then you have to get acquainted with the biological effects of the radiation, and also you have to be familiar with the dose concepts. This will cover all the knowledge for you to understand the application of radioisotopes in nuclear medicine. Thank you for watching this video. I hope you will like this course.